Hello everyone, welcome to today's lesson. Today we're going to be talking about the difference of two squares. And I need you to write down this first sentence for me. An expression in the form a squared minus b squared is called the difference of two squares. It's often necessary to factor the difference of two squares, and with practice it's easy to get good at recognizing them. This thing is very similar to something that we did last week whenever we were multiplying things. You should have seen that sometimes whenever you multiply certain factors, some of the pieces are going to cancel out. When you do a times a, it makes a squared. A times negative b makes a negative ab. B times a makes a positive ba. And then we're going to subtract b times b, which makes b squared. This ab and BA are actually the same thing because we're multiplying. You can rearrange the BA to look just like AB. Once you have a negative version and a positive version of the same thing, they cancel out, and it only leaves you with the A squared and the negative B squared. And that's how we get this side of the formula. So A squared minus B squared is always going to factor to be two binomials. What you put in the factor for a is always going to be whatever the square root of this a squared term is. What you put in the factor for b is always going to be what the square root of this b squared term is. And you're going to put a and b in one of the factors and in the other factor, but one's going to have a plus sign and one's going to have a minus sign. If these hints are useful to you, write down these hints, and then I'll show you some examples in a second. The thing about a difference of two squares is that a lot of times it only has two terms because the middle term canceled out whenever you multiplied the binomials. So this term has 4x squared. So what would need to be squared to make 4x squared? What would need to be squared to make 4 would be a 2, and to get x to become an x squared, we would just need a single x. And so that's going to be the first part of both of our factors. Let me write the formula right above. This one has all of the x's, and this right term has all of the y's. There's nothing here that combines both x and y together. Then we can just use this formula whenever we factor. So what needs to be squared to make 25? It's going to be a 5. And what needs to be squared to make y squared? It'll be a y. So we're going to have a plus 5y and a minus 5y. And this is our factored answer. We can check this using the x method. B is 0 and c is negative 25. This is your first time seeing an example like this, but if we set up our a, b, and c the right way, then we can factor this just fine. So a times c will go on top. That's going to make a negative 100 on the top and a 0 on the bottom. Things that multiply to be 100 are 10 and 10. To make them a negative 100, one of these needs to be negative. We're then going to divide by our a, which is 4. This right side reduces down to make negative 5 halves, and the left side reduces down to make positive 5 halves. That means our factors, I'll use a different color. Our factors are going to be x plus 5 over 2, x minus 5 over 2. But since we have a y, it's not just the 25. Since we have a y, we have to also put a y on that term. So we can still use the x method. We just have to not forget a couple things. You can just pretend that the y squared is not there while you're using the x method, and then you throw the y in at the end. Then we change it from the fraction form to the form of this answer that does not have a fraction. So we're going to move this 2 to be times x, and that'll leave you with 2x plus 5y. We're going to move the other 2 to the x, and we have 2x minus 5y. And there it's factored. That example may have seemed complicated, but if we do this next one, if we do number 5, I think you'll see it's not so bad. This was just one of the more difficult first examples I could have shown. All right, so let's do the second one. The formula is a squared minus b squared equals a plus b times a minus b. So whatever this first term is, what needs to be squared to make 16? It's a 4. And since the variable is y, we're going to put a y on that 4. And that's going to be for both of these terms because a goes there and a goes there. So we have the same thing for the first term in both of our binomials. Then, what squared makes 81? Well, that's just the 9. 9 times 9 makes 81. We need a positive version and a negative version. Let's check and make sure that we get the same answer even if we factor it using the x method. A is 16, B is 0, C is negative 81. 16 times negative 81 is negative 1296. And B is 0. Luckily for me, I know my perfect squares, and I know that 1296 is 36 times 36. We need one of them positive, one of them negative. And with that, now whenever I add those 36s together, they make the number 0. And when I multiply them, I make negative 1296. Then we just take that and divide it by a. We can reduce these by 4. 4 fits into 36, and 4 fits into 16. The top becomes a 9, the bottom becomes a 4, and we'll have the same thing on the left, but positive, 9/4. So I'll have y plus 9/4 and y minus 9/4. Then we change it to the form that does not have a fraction. So that 4 is going to multiply y. We're going to add 9. The 4 is going to multiply y, and we're going to subtract 9. And we see we get the same answer both ways. So yes, the x method works for everything. As long as it's a trinomial, and as long as it can be factored, the x method works. That's why I showed that to you yesterday first, before I had you learn random specific formulas, like we're learning today. So make sure you have this formula written, and you title this the of two squares. I'll show you 2 more examples in the next video.